welcome to my blog. In this video, we're going to calculate the percentage of composition. So this is the problem of composition. Find the percentage of each element in aluminum oxide. So first thing we need to do is we need to calculate first the formula mass of aluminum chloride. Okay. In number 1, we need to calculate first the formula mass. So in aluminum, they have 2 moles. So 2 moles of aluminum and 3 moles of oxygen. So equals 2 times the molecular weight of aluminum, which is 26.97, equals 3 times 16, so equals 2 times 26.97 is equals to 53.94, and 3 times 16, which is 48, so you need to sum all 53.94 plus 48 is equals to 101.94 grams per mole of aluminum oxide. So that's it. But first, we need to calculate each percent by its element. So, percent of Al is equals to 53.94 divided by the formula mass, which is 101.94. So, there's a grams per mole and grams per mole again, and then times 100%. So you need to cancel out grams per mole. On the left is percent. So percent of aluminum is equals to 53.94 over 101.94 times 100%. So equals 52.91%. Okay, and that is the answer, the percent of aluminum. And how about percent of oxygen? Percent of O is equals to 48 grams per mole over 101.94 grams per mole. So times 100%. So percent of O is equals to 48 divided by 101.94 times 100% is equals to 47.1%. So that's it. Oh, you can have a choice. Percent of O is equals to 100% minus the percent of aluminum. So equals 100% minus 52.91%. So 52.91% is equals to 100 minus 52.91 is equals to 47.1%. Alright, it's the same here. The same. You can choose either. Okay, let's proceed in letter and number 2. In number 2, find the percentage of nitrogen in ammonium nitrate, an important compound used in the manufacture of matches and as the source of nitrogen fertilizer. So the question is, you need to find the percent of nitrogen in ammonium nitrate. So first of all, you need to calculate the formula mass of ammonium nitrate. Okay? So in nitrogen, so let's write again the formula, ammonium nitrate. So calculate the formula. So nitrogen has 2 moles of nitrogen and hydrogen has 4 moles and oxygen has 3 moles. So equals 2 times the molecular weight of nitrogen, which is 40.01, then 4 times the molecular weight of hydrogen, which is 1.008, then 3 times 16 is equals 2 times 14.01 is equals to 28.02. 4 times 1.008 is equals to 4.032. Then 3 times 16 is equals to 48. Then find the sum. 28.02 plus 4.032 plus 48 is equals to 80.052 grams per mole of ammonium nitrate. Okay, that is the formula mass. But the question is, find the percent of nitrogen. So percent of nitrogen is equals to the molecular weight of nitrogen, which is 28.02 grams per mole, over the formula mass, which is 80.052 grams per mole, and then times 100%. So cancel out grams per mole, and the left is percent. So percent of nitrogen is equals to 28.02 divided by 80.052 times 100%. So equals 35% of nitrogen. So this is all. And that is your final answer. Okay, how about number 3? We have a number 3 problem. Copper 2 sulfate pentahydrate is a blue compound used to make the color pigments, insecticides, and electric batteries. So calculate the percent of oxygen and the percent of water in copper sulfate pentahydrate. So first thing we need to do is you need to calculate the molecular formula mass first. So you need to write the formula. So in number 3, we have a copper sulfate pentahydrate. So calculate first. They have a 1 mole of copper, 1 mole of sulfur, and 4 moles of oxygen. 4 moles of oxygen and 5 molecules of water. Okay, so equals 1 times, what is the molecular mass of molecular weight of copper, which is 53.5, equals 1 times 32.06 is equals to 4 times 16 is equals to, what about the molecular weight of water? So we need to find the molecular weight of water. The molar mass of water is equals to 2 times 1.008 plus 16 is equals 2 times 1.008 plus 16, so equals 18.02 grams per mole of water. So in here, so 5 times the molecular mass, which is 18.02 equals, so 1 times 53.55, which is 53.5. No, this is 63. I'm sorry. 63.5. 1 times 32.06, which is 32.06. 4 times 16, which is 64. Then 5 times 18.02. 18.02 equals to 90.1. So you need to add all, find the sum. So 63.5 plus 32.06 plus 64 plus 90.1 is equals to 249.66 grams per mole of copper sulfate pentahydrate. Okay, now we need to find the percent of oxygen. So here, percent of oxygen. In letter A, find the percent of oxygen. So percent of O is equals to 5 plus 4, which is 9, so 9 times 16, or 64, 9 times 16, so 9 times 16 grams per mole over the formula mass, which is 249.66 grams per mole times 100%. So percent of O, so 9 times 16 divided by 249.66 times 100 is equals to 57.7 57.7%, and that is your final answer. Then how about letter B? Letter B, the percent of water. So in letter B, the percent of water is equals to, here the molar mass of water, which is 90.1 grams per mole, over the molar mass, which is 249.66 grams per mole times 100%, then cancel out grams per mole, Then a percent of water is equals to 90.1 divided by 249.66 times 100%. So 36.08% or 36.1%. And that is your final answer. Okay, and how about in number 4? Right, in number 4, an ore is a compound or mixture of elements or compound that must be treated in some way to obtain the pure element desired. So ore equals useful metal plus waste material. Calculate in kilograms the amount of iron available from 50 kilograms. So this is a 50 kilogram here of iron ore hematite if the ore contains 60% of iron 3 oxide. So we have a given here 50 kilogram of iron ore and 60% of iron 3 oxide. So let's begin in number 4. So in number 4, we need to calculate the mass, formula mass first. So iron 3 oxide. So iron 3 oxide. So we need to calculate the formula mass. So 2 moles of iron and then 3 moles of oxygen. So equals 2 times 55.85 equals 3 times 16. So equals 2 times 55.85 is equals to 111.7, and 3 times 16 is equals to 48. Then 111.7 plus 48, so 159.7 grams per mole of iron 3 oxide. So is a formula mass. So we need to calculate the kilograms of iron. So kilograms of iron. Kilogram of iron is equals to 50 kilograms of iron ore times 60 kilogram of iron 3 oxide, so 60% over the kilogram of 100 kilogram of iron ore times the 112 kilogram of iron divided by 160 kilogram of iron 2 oxide. So cancel out 159.7 is a run out of 160 and 111.7 is a run out of 112. So cancel out. So they have a kilogram of iron equals 50 times 60 divided by 100 times 112 over 160 is equals to 21 kilograms of iron. So that's it. Let's continue to number 5. later.